check the following matrices are Hermitian as well as unitary. This is the problem of iitjampyq 2024. We will go through the every examples and check one by one whether they are Hermitian and unitary or they are satisfying the both conditions. We will go through the shortcut tricks and detail. So we need a matrix which is both Hermitian as well as unitary. Hermitian means a dragger equal to a dragger means a complex conjugate transpose or a transpose complex conjugate equal to that matrix. Or unitary means a dragger into A equal to identity matrix. How to check? Principal diagonal element of a Hermitian matrix is always real. Off diagonal Hermitian means a dragger equal to A. Dragger means a complex conjugate transpose or a transpose conjugate equal to that matrix. Here we see as an example a matrix A whose elements are A, D, E, D star, B, F, E star, F star, C. Here A11 is A, A12 is D, A13 is E, A21 equal to D star, A22 equal to B, and so on. So here we see the diagonal element ABC which belongs to real number, and the A12 element which is D which is direct complex conjugate of A21. A13 element E is direct complex conjugate of A3 on element. So we can conclude that for Hermitian matrix diagonal elements are real and the off diagonal elements are complex conjugate of each other. So the minimum number of real element of n cross n general matrices are n. So for a 3-3 Hermitian matrices the real element is 3 which is diagonal element. For in case of unitary matrix any two row and columns are orthonormal means A square = identity matrix. So in case of option A matrix equal to 0, -1, I0. So we take the transpose of that matrix which is 0, I, -I0. Then we take the complex conjugate 0, -I, I0. So it come back to original matrix. So a dragger equal to A. So this is an Hermitian matrices. So in case of checking unitary matrices, we know the condition is A dragger A equal to identity matrix. So we already know A dragger equal to A as A is a Hermitian matrix. So we can put, so we get A square equal to identity matrix. So if you check the option A as a unitary, so you can multiply A with A and you get 1001 which is a 2 order identity matrix. So A square equal to I. So the first option is both Hermitian as well as unitary. So we check the other few options. Here we check the other options. The second option 0I, I0. So here the diagonal elements are real but the off diagonal elements are not conjugates. I here should be -I. So A dragger not equal to A, so it is not Hermitian, no question of checking unitary. Option number B, here we get the diagonal elements are real and the off diagonal elements are complex conjugate of each other. So A dragger equal to A, so they are Hermitian. But if we check the A square which is 2, so in case of unitary A dragger A equal to identity, here we can't get identity. So this is not an unitary matrices. In case of fourth option, the off diagonal elements are complex conjugate of each other, so it is Hermitian and the diagonal matrices are real, but A square equal to 2 which doesn't satisfy the unitary condition. So both the conditions satisfied by the option A.